So, while all this was happening in Europe, what was happening in India? As we have said earlier, the Indus Valley civilization was approximately 3500 BC to about 1700 BC. And then the Vedic age was around 1500 BC to about 600 BC. And then after that we call the post Vedic age, which is around say 600 BC to, I will not define exactly when it was, but let us discuss this period. I will not talk about the Indus Valley civilization because apart from technology used there, we do not really know much of the thought process or the science that was there. But in the Vedic age, whatever science was there, we can get some glimpse of it from the Vedic literature. And we know that during that time, well, initially in the Vedic age, writing was not there. So, things were propagated in Shruti and Smriti, but after around 1000 BC, writing developed and things started being written up. And at that time, we get some glimpse of the number system they used. In the number system they used, it was a 10 based number system, but there was no 0. There was no place value system. So, in their number system, it was basically 1, 2, 3, 4, 5, 6, 7, 8, 9, and then since there was no 0, one cannot write 1 0 as 10. So, there was a separate symbol for 10, and that symbol followed by 1 would be 11 and so on and so forth. Again at 20, you will need a separate symbol, and this method of writing continued for a long time. In fact, the Kharoshthi stone inscriptions at the time of Ashoka also has the same number writing system. One important development that happened in the Vedic age was the Sulva Sutras. Sulva Sutras was, the word means the rule of the thread. Sulva means thread. So, essentially these were instruction manuals for constructing altars for yagnas, and in that they had to tackle some theoretical problems. For example, how to identify the exact east-west line. They could figure that out. How to construct a circle of the same area as a square, or how to construct a square of the same area as a circle. So, these are problems that were tackled in the Sulva Sutras, and we see in the Sulva Sutras the first statement of what is today known as the Pythagoras theorem. As we have seen that the Vedic age, essentially we say that the onset of the post Vedic age with the onset of the Jainism and Buddhism, because after about 100 years of Buddha's life, practically the whole subcontinent became Buddhist. And so, after that time we say that the Vedic age had ended and the post Vedic age has started. And in this transition period, we see a lot of developments, and in the early post Vedic periods, we see a lot of developments. Most notably, there was a development of medical science. Towards the end of the Vedic age, we see the Atharva Vedas being written up, And in the early post-Vedic period, in continuation of that Atharvaveda tradition, the Ayurveda was written up. And we see great medical practitioners like Charaka, Sushruta in that early period of the post-Vedic age. Sushruta in fact introduced surgery, and that is unprecedented anywhere in the world. Surgery per se was not practiced anywhere in the world at that time, so it was a great development for that matter. In the Vedic age, Sanskrit was developed as a language, but it did not have a uniform form. And Panini, the greatest grammarian of antiquity, Panini, I was so far talking about the Atharvaveda and Ayurveda, and we talked about Sushruta, Charaka, and there were other important medical practitioners. For example, Atreya, Jivaka. Jivaka was the court physician of Bimbisar. And I'm talking about now of Panini, the greatest grammarian of antiquity, around 5th century BC. So Panini actually formalized Sanskrit grammar and gave it a very structured form so that it could become the link language of the whole Indian subcontinent. Link language, not only link language, but also the language of the educated class. And the way we write our alphabets, that's also a contribution of Panini. So Panini was one of the greatest grammarian of antiquity. And after that, we find that the Jains, the Jain lineage created a group of mathematicians called the Jain mathematicians. So far in the Vedic age, the mathematics that I just mentioned in the Surva Sutras, these were mathematics for the service of religion, religious practices, while the Jain mathematicians took it out of the religious practice and made mathematics stand on its own feet. They conceived large numbers, even infinity, and things like that. The greatest development in the post-Vedic age in mathematics was the introduction of zero. The absence of anything is also a number. Conceiving that was not easy. That happened in the Indian subcontinent, though I must admit that at that time there was trade between India, China, Indochina and all those regions, and it is somewhat uncertain as to where zero originated first, because the idea could have originated in any of these places, and through trade routes that might have come to the other places, because the oldest inscription of the symbol zero is found in a temple in today's Kampuchea. So it is not in the Indian land per se. But nevertheless, it is normally believed that early on Indians took up this zero and the place value system. And when you introduce a new kind of writing numbers, the whole mathematics has to be redone. So the ways of addition, subtraction, multiplication, division, square root and all that had to be invented afresh, was done in Indian subcontinent. And then we see a plethora of great mathematicians and astronomers. We see Aryabhata, 5th century. We see Varamihira. We see Brahmagupta. Sorry. After Brahmagupta, there were, say, Sridhara was there. Sorry. And there were many such mathematicians, but crowning all that was Bhaskara. I would say Bhaskara 2 because there was another Bhaskara 1. He was in the 12th century. Aryabhatta was in the 5th century. And they were in between 6th century, 7th century, he was in 9th century, and so on and so forth. So, in this period, we see a lot of developments. What did they do? Aryabhatta, for example, found the value of pi much more accurately than anybody contemporary to him. He expressed it as a fraction, but when you evaluate that, you find that 3.1416 is correct. At that time, astronomy and mathematics was developing hand in hand. The primary incentive for doing mathematics came from astronomy, because things in the sky always aroused curiosity. People had been looking at the things in the sky primarily, initially, for the purpose of making a calendar, because calendar is necessary in any agricultural society. So, in order to make a calendar, you have to find some repetitive events, cyclic events, and the motion of the sun, the motion of the moon are such cyclic events. So, the ancients of India at that time minutely observed the motion of the sun and the moon. They observed that the sun does not rise in the same place every morning. So, it goes towards south and then again goes towards north. So, the Uttarayana and the Dakshinayana, those things were identified, and when it reaches the last point in the north, when it is the last point in the south, these were identified. Not only that, people realized that the sun and the moon go in a particular strip, and all the planets go in the same strip. Today we know that as the zodiacal strip. And in order to identify the position of the sun and the moon, the ancients in India named 27 stars along that zodiacal strip. They named the Rashis that we know today, the constellations, the Leo, the Libra and all that, those constellations were named. Aryabhatta for the first time realized that we see the sun going from one side to the other, from the east to the west. We see the moon going from the east to the west. We see all the stars, the whole sky going from the east to the west. And he realized that the easiest solution of all that is to assume that the earth itself is spinning on its own axis. This was the first in the world when somebody could make the comment that the earth itself is not static. It is in fact a spinning globe. The people contemporary to Aryabhatta, even a century, couple of centuries later, like Varamira, Brahmagupta, they did not accept Aryabhatta's idea that the earth is a spinning globe, but they also had their own contribution in mathematics and astronomy. Well, Brahmagupta, for example, Aryabhatta was not the first to introduce the sine tables and cosine tables, because as I said earlier, the Greek astronomers, Aristarchus and Hipparchus, they introduced the sine and cosine in order to make their observations correctly, and Aryabhatta made a sine table of 1 degree difference. So, sine 1 degree, sine 2 degree, sine 3 degree, cosine 1 degree, cosine 2 degree, he made tables like that. And when we really look at the tables, we find that it satisfies the sine square plus cos square equal to 1 rule. So, that rule was also definitely known to them. And whatever trigonometric relationships we learned in school, the simple ones, all these were invented by Aryabhatta, Varamira, Brahmagupta. In fact, in Brahmagupta's book, Brahmasfuta Siddhanta, you see practically most of the simple trigonometric relationships that one learns in school today. So those things were introduced in the Indian soil. Algebra. Algebra was done using Sanskrit alphabets. Ya was to represent today's X. And if there was X and Y, that means two unknowns, then that was represented by the first letters of the color names. So red and blue, the first letters, Sanskrit letters of the color names were used, and people wrote equations with that. Not only that, one of the peculiar mathematical developments in India was the solution of indeterminate equations. Something like ax plus by is equal to c. An equation like that, one equation like that cannot be solved because there are two unknowns. But some Indian mathematicians noticed that if a, b, c are whole numbers and x and y are also whole numbers, then there are solutions. And they found such solutions. And through that, you can see Sridhara Brahmagupta introduced what is known as the quadratic equation and its solution, and it was formalized by Sridhara. So sometimes it is called Sridhara's equation. And the last of that that sequence of mathematicians was Bhaskara. He was a great mathematician. In all fields of mathematics he had contributions, and I will not elaborate on each of them. All that I want to point out was that after Bhaskara there was practically nothing. At least in the main part of India, there was one lamp still lit in the corner of the Indian subcontinent in Kerala, which is called the Kerala School of Mathematics and Astronomy. They were followers of Aryabhatta and continued that tradition and developed mathematics at a later time. But after the 11th century, practically science was dead in India. Bhaskara was, you can say, an outlier. He was actually not in northern India. He was in today's Karnataka. His place was in today's Karnataka. And after that, center of learning moved further south in Kerala. Well, so you see that in India also a lot of developments happened. And in the last class I pointed out that in India also both the materialist school as well as the idealist school existed, were fighting for intellectual space, were influencing people. For example, the names that I mentioned, Sushruta, Charaka, Aryabhatta, most of them subscribe to this or that school of materialist philosophy. But the idealist philosophy was also very much there. And in the 7th century, idealist philosophy started on an ascent with the work of Shankara. He forcefully made the point that the world is illusion. The material world as you see it is illusion, is Maya, and following his time, slowly the ideal school became stronger and stronger, and as a result the materialist school became weaker and weaker. And Acharya P.C. Ray identifies the decline and fall of science after the 11th century to 3 factors. In his book, The History of Hindu Chemistry, he writes that the first reason for the decline started around 9th century, and after the 11th century it was practically not there. Science was not there in India any further. So he identified that as the ascent of the caste system. Caste system was there earlier, but it was not entrenched in the society in a very strong manner, and after that time it became a very strongly entrenched caste system. Prafula Chandra makes the point that in order for science to flourish, the doers and the thinkers either have to be the same people or have to be in close touch with each other. But after the caste system was introduced, the doers and the thinkers were separate castes with no contact between them. The second point he made was that specifically in the context of these medical practitioners, because as I said, surgery was the important thing they introduced surgery. Prafulla Chandra made the point that in order for a teacher to teach surgery to a student, you cannot do it without dissecting dead bodies. By dissecting dead bodies, you can show what is inside and in which position, so that when you actually perform surgery on a living body, the person must know what is cutting and where to find what. When the Manu, the strictures of Manu, the Manu Samhita was introduced, then it became impossible for a Brahmin or somebody of the upper caste to touch a dead body, a cadaver, because that was only to be done by a Shudra. So the learned people no longer could touch the dead body, so dissecting the dead body became impossible, and naturally the whole cult of surgery fell into disuse. The third point that Prafulla Chandra makes is that the ascent of the philosophy of Shankara, which saw the idealist philosophy of Shankara, which saw the material world as illusion. He says that in order to do science, you have to believe that the material world exists. You have to ask questions about the material world and have to seek answers. If you believe that the material world is an illusion, you can do no science. So when this philosophy captured the intellectual space, then science slowly died out. So as you can see that there was a eclipse period of science in Europe during the Middle Ages. There was an eclipse period in science during the in India also, that lasted from about started, as I said, in the 19th century, and after the 11th century it was practically eclipsed. There was no science in India for that matter, except the few work that we find in the Kerala School of Mathematics. And again India started doing science proper in what is known as the Indian Renaissance, when Raja Ram Mohan Ray and Vidyasagar in the 19th century, they were enlightened by the ideas of European Renaissance. They brought that idea of European Renaissance and tried to enlighten the Indian populace. Vidyasagar tried to change the Indian education system, and through that a new cult started, the cult of doing science. And in the next stage we see a great number of mathematicians and scientists. We see Jagadish Chandra Bose, we see Prafulla Chandra Ray, we see Raman, we see Ramanujan, we see Meghnad Saha, Satyendranath Bose, and many others. Great scientists doing great science in a very difficult situation. So India also had its very rich history of doing science. India also had its history of science being eclipsed by idealism, and again the ascent of science at a much later period. In the next class, we will continue our journey with European science, because then a lot of things were happening in Europe. But before leaving the history of science in India, let me tell you that in India, a lot of fantastic developments happened in science, which influenced the science of the rest of the world. The science of Aryabhatta, Varamihira, Brahmagupta, and people like that, where the books by them were translated by the Arabic scholars, and when there was a the golden age, as it is called, the Islamic golden age, where the center of learning was practically in Baghdad and places like that. There the Khalifas employed people to get literature from different places and to translate them into Arabic, and they translated these books by them. Not only that, an Indian scholar was invited by the Khalifa in Baghdad, and he stayed there for some time and conveyed our number system to them. And then the Arabic world accepted our number system, the zero, the place value system, the decimal system, and that from them the Europeans got it. And that is why these numbers are still called the Arabic number systems, but actually these were originated in the Indian subcontinent. And through the exchanges that happened through trade routes, especially after Alexander's invasion into India, the Greeks had their colonies, not colonies, their empires in different places in the Middle East, and various Indian states had trade relationship with them. So the Greek ideas reached India, the Indian ideas reached various other places in Europe. So the developments that happened in India did not really remain in India. It spread in other places and influenced. Arabic astronomy was influenced by Indian astronomy, but the Arabs developed it further, and their specific focus was on making star charts, and they called it Zij. They produced various star charts, and again when Indian science was eclipsed, those star charts came back to India from the Arabs, and their mechanism of producing the star charts was by using great observatories, masonry based observatories, and those things were actually perfected in the Arab world and came back to India. So there was exchange of ideas between the Arab world, between India and the European lands, but very little during the dark age of Europe. Only after the Renaissance started, they translated the work of the Arab scholars, and Arab scholars in turn had inherited some of the knowledge from the Indian scholars. So there was a exchange of ideas. Many of these had actually originated in India. We have to be proud of that. But I must also say that we should not, we should understand what really happened in India, rather than harboring fanciful ideas regarding things that actually did not happen. There was no aircraft in India. There was no plastic surgery that could plant elephant head on human torso. There was no stem cell research in India at that time. There was no biotechnology that could give birth to 100 sons of one lady. So these are actually mythological stories. We should not put any science behind them, but these are hard science that was done in Indian soil, and we have to be proud of it.